Good afternoon, everyone. So today we are going to talk about legacy databases and address a fundamental challenge in data security. How do you genuinely protect your most sensitive information, i.e. the PIIs, the personally identifiable information, from everyone? Now, I would like you to think about all the powerful administrators outside and inside of your organization who can potentially see these clear text PIIs. You have the server administrators, the cloud administrators, and obviously the database administrators, the one with the highest privileges and direct access to the database itself. So now, how do you secure your sensitive data within your existing database infrastructure and ensure that no one, not even the trusted admins, can see it when it's being processed? So that's where Klave DB, powered by confidential computing, fundamentally redefines the trust model. First, Klave DB doesn't run inside your existing database server or environment, and instead, it will establish a secure connection to your existing database instance, will encrypt deterministically all your PIIs with cryptographic keys that will never leave the enclaves. This will remove from all the trusted administrators any access to the PIIs in clear text. If they ever try to have a peek, they will only see encrypted PIIs instead of clear text. Basically, thanks to Klave DB, your legacy databases are secured and data will stay where it is. Okay, now let me do a demonstration of Klave DB capabilities on a real use case. I'm going to start with pgadmin, which is a client on PostgreSQL database, and I built 3 different tables, the users with the different PIIs. That's the basic use case: first name, last name, email, gender, address, everything that you can find in a standard PIIs. Then a products table that users can buy, and different purchases made by the users. So as an example, I will do 3 types of queries with different joins on the tables with the PIIs. So here, all the purchases that have been made by Daniel Baker. So you can see that Daniel Baker has bought some boots and some sneakers. Try to remember that because we should be able to replay it within Klave. Then a second query, which gives me the average age of men spending, who spend more than £300. That's 43.9 years, and then the same for women, and that's 44.8 years. So for all these queries, all the results appear in clear text. So this is the base case for Klave DB. Now, let me move to Klave. So here, this is Klave in production, and I have deployed an application that I've written in Rust. So that's my Rust application. I'm just going to show you the width, which shows 5 different APIs. So the first API, DB setup, allows me to set up the database to connect with. The second one executes the deterministic encryption on all the PIIs. The third one, fourth and fifth, or read encrypted data per user, the average age for male and average age for female, corresponds to the 3 queries that I've shown you previously on pgadmin. So now let's go back to Klave, and first we are going to execute the deterministic encryption on the table users. I'm going to use the same ID as the one that I have set up previously, and the columns will be encrypted. So the PIIs column are first name, last name, email, address, city, and gender. Let's execute the encryption, and it should take a few seconds to encrypt all. That's it, the users have been successfully encrypted. Let's go back to pgadmin. Particularly, let's just have a look to the users table. All the PIIs should have been encrypted. Yes, first name, last name, email, gender, address, and city. Perfect. Now, let's show you that within Klave, we are still able to query as if we were querying the database in a non-encrypted manner. Go back to Klave, and I'm going to first execute the read encrypted data per user. So I'm going to retrieve the input. And I'm going to give here and read encrypted data per user. If you remember, there are two outputs, so they bought some boots and some sneakers. Okay, perfect. We get exactly the same output as with pgadmin. Now, second and third query. I will replay the same queries to understand the purchase structure by gender. So first one, average age for female. Here, all the logics is coded within the root, so I just need to provide a database ID. 44.8 years, so that's for women, and for male, 43.88 years. So I've basically got exactly the same results as with non-encrypted data. So as a conclusion, I would like to remind you all the properties that make Klave DB unique in its approach to secure legacy databases. So first, and the most important, the data stays where it is. Klave DB will encrypt deterministically your PIIs and secure its encrypted keys within its enclaves. This particularly allows to make the process seamless and keeps all the critical database operations available on encrypted PII columns. We believe this whole process significantly reduces the complexity of adopting advanced security such as Klave. Thank you very much.